There are 9 layers of the universe stacked inside each other, and the last one is completely insane. The final layer has infinite copies of you making infinite different choices right now. We're covering all 9. We're going from atoms to the multiverse in 10 minutes. No fluff, no filler, just the ladder. Not all layers of reality are the same. Some you live inside, some you'll never actually see. And the last one on this list might not even exist. I'll walk you up rung by rung. Each rung gets weirder than the last one. Start small, smaller than you probably think right now. Quick ground rules. A layer here means a scale of structure, something built out of the layer below. We're starting subatomic and ending at the multiverse. No jargon without an immediate translation into plain English. No pretending anyone fully understands this. And no filler because we've got a lot of ground to cover. The ground literally stops making sense halfway through, and the layers get stranger and stranger as we climb. By layer 7, your intuition is already useless. That's fine. Intuition was built for savanna problems, not this. The first layer is inside you right now. Layer 1. Subatomic, the floor of reality as we see it. Here's the thing. Everything you've ever touched is built out of a very short list of ingredients. Quarks clump together to form protons and neutrons. Electrons orbit those tight clumps in fuzzy probability clouds. And force carrier particles called bosons, which are basically tiny messengers passing forces between every other particle in existence. That's essentially the entire cast for ordinary matter. 6 quarks, 6 leptons, and a handful of bosons. That's it. That's the universe's complete inventory list, and everything else is these ingredients stacked into shapes. Here's the part that breaks people. Atoms are almost entirely empty. Not mostly empty. Aggressively, weirdly empty. Scale a hydrogen atom up to the size of a football stadium. The nucleus is a marble at center field. The electron is a dust speck in the nosebleed seats. Everything between them is literally nothing at all. You are essentially 99.9999% empty space held together by electromagnetic force. The chair you're sitting on is empty. The floor is empty. You don't fall through because empty parts repel. Go smaller. Underneath particles are quantum fields. Every particle is basically a ripple in an invisible field filling space. Electrons are ripples in the electron field. Photons are ripples in the electromagnetic field. Reality is not stuff, it's vibration in fields you cannot see. And beneath that sits a hard floor called the Planck length. At 10 to the minus 35 meters, space itself stops behaving like space. Distance simply loses meaning. We don't know what's underneath, and physics as we know it literally cannot even ask the question. Stack all of this and you get everything you've ever touched. Layer 2. Atomic and chemical, basically. Atoms link up into molecules. Molecules link up into dust, rock, water, DNA, coffee, essentially everything you know. This is the layer where chemistry lives, and chemistry is basically electrons trading places to make bigger clumps. Boring? Sure, but this is the only layer where you personally exist, so pay it some respect here. Every atom heavier than helium was literally cooked inside a star, then blasted out when that star died. The iron in your blood was forged in a supernova. You are, bluntly, recycled star guts with opinions. Zoom out. Dust clumps into rocks, rocks clump into asteroids, asteroids clump into moons and planets. Gravity does the assembly. Give it a few 100 million years and you get worlds. Rocky ones like Earth, gas giants like Jupiter, ice giants like Neptune, weird failed stars called brown dwarfs that couldn't quite get the fusion going properly. All of them are just gravity's leftovers spinning around the actual main event, which is the star, obviously. Layer 3, if you're counting along. A star is basically a giant ball of hydrogen crushing itself so hard that its own atoms fuse together and release energy. That's it. That's essentially the sum in one sentence. It's a controlled nuclear explosion that's been running for 4.5 billion years already, casually burning. It has roughly another 5 billion left before it swells up, eats Mercury and Venus, and sterilizes Earth. Casual. Stars come in flavors. Red dwarfs are small and stingy, burning quietly for literally trillions of years. Yellow dwarfs, like ours, middle of the road. Blue giants, massive, hot, and dead in a few million. When big stars die, they collapse into neutron stars or black holes. A neutron star is city-sized, but weighs more than the Sun. A sugar cube-sized piece of one would weigh 1 billion tons. Insane. Black holes are what happens when gravity wins so hard that not even light manages to escape out. Stars are basically just neighborhood decor at this scale. Zoom out further. Layer 4. Solar systems. A star, its planets, its moons, its asteroid belts, and the giant magnetic bubble called the heliosphere, which pushes back against interstellar space. Our solar system is about 120 astronomical units across, if you count the heliosphere. An astronomical unit is basically the distance from Earth to the Sun, so the Sun's bubble is 120 of those. Sounds big. Here's the thing, it's nothing. Because now we jump from astronomical units to light years. 1 light year is about 63,000 astronomical units. The nearest star system is Alpha Centauri, 4.2 light years away, and that's the neighbor. At the fastest speed any human object has ever traveled, it would take 6,000 years to arrive. Between stars sits mostly emptiness, dust clouds, and stellar nurseries, huge regions where gas collapses to form new stars. This is where suns are born and eventually die. Stars are basically neighborhood decor. Now zoom out again. Layer 5. Galaxies. A galaxy is a gravitationally bound gang of stars, gas, dust, and dark matter, usually a few 100 billion stars strong. Ours is the Milky Way, a big barred spiral galaxy shape. It's about 100,000 light-years across, and the Sun sits in a boring suburban arm called Orion. Galaxies come in 3 main types. Spirals have pretty arms. Ellipticals are basically fuzzy footballs of old red stars. And irregulars, the misshapen ones that got smashed up or never quite got their act together. At the center of almost every big galaxy sits a supermassive black hole. Ours is called Sagittarius A star. It weighs 4 million suns. Others in different galaxies weigh billions. That scale alone is hard to picture. How they got that massive that fast in the early universe is one open embarrassment of modern physics. Around every galaxy sits a halo of dark matter, invisible stuff that outweighs visible stars 5 to 1. We can't see it or detect it. We know it's there because galaxies spin too fast to stay together. There's more of it than us, and we still have absolutely no idea what it actually is. Galaxies also travel in packs. Milky Way, Andromeda, Triangulum, and about 80 smaller satellites form the local group. There are an estimated 2 trillion galaxies in the observable universe. The Milky Way is one dot among trillions. But here's where it gets weird. Galaxies clump together, and the pattern of that clumping is genuinely disturbing. Layer 6. The cosmic web. Galaxies aren't scattered randomly, they cluster. Groups of tens clump into clusters of thousands. Clusters clump into superclusters. Our local group sits inside a supercluster called Laniakea, 500 million light-years across. Laniakea contains 100,000 galaxies, all flowing toward a mysterious gravitational point called the Great Attractor. But zoom out further and something spooky shows up. Superclusters connect through vast filaments of galaxies, bright glowing strands. These strands stretch for billions of light-years. Between them lie voids, enormous, mostly empty regions where there's basically nothing. The Boötes void is 330 million light-years across, containing maybe 60 galaxies where you'd expect 10,000. Basically a hole in the universe. At the largest scale, the cosmos itself looks eerily like a giant brain. Bright filaments, dark voids, nodes at the intersections. Cosmologists literally compare it to a neural network firing across space. Whether that's meaningful or just primates seeing faces in toast, nobody knows. And this isn't even the biggest layer. Layer 7, the observable universe. This is the boundary of everything we can, in principle, ever see or detect. It's a sphere about 93 billion light-years across, centered on you. Yes, you. Every observer gets their own. Every observer's observable universe is centered on themselves. It's not that the universe is only 93 billion light-years wide. Light simply hasn't had time to reach us from further. The universe is 13.8 billion years old. But space itself has expanded, so the sources of the oldest light we see are 46 billion light-years away. That's in every direction. Double it and you get the diameter. 93 billion light-years of visible cosmos surrounding you. At the edge of the sphere is a wall. Not a physical wall, a time wall, the cosmic microwave background. It's leftover heat from when the universe was 380,000 years old and finally cooled down. Before that, everything was a glowing plasma soup. Light couldn't get through. We literally can't see past that moment. Basically, the oldest photograph in existence. Identical in every direction to 1 part in 100,000. Here's the worst part. Dark energy is accelerating the expansion of space, meaning the observable universe is actually shrinking. Every day, more galaxies cross an invisible line and become permanently unreachable, even at the speed of light. Eventually, every galaxy outside our own supercluster will be gone from our sky. Just local stars remain. Our descendants will look up, see nothing but local stars, and conclude the universe is small and static. They'll be wrong, and here's the thing, they'll have absolutely no way to ever know it. Layer 8, beyond the observable. The universe almost certainly keeps going past everything we can actually see. It might be 100 times bigger, 1 billion times bigger. It might just be straight up infinite. We have no way to check, because that light will never reach us. Permanent blind spot, essentially. Physics says it should look the same as our patch. Same laws, same galaxies, same dark matter. But that's faith, because the alternative is reality has an edge, and edges are worse than infinity. If the universe is truly infinite and matter distributed roughly evenly, every possible arrangement of atoms has to repeat. Which means there's a version of you reading this exact script in an exact copy of this room. Statistically, not spiritually, just math. The least comforting kind of infinity. And still not the weirdest layer. Layer 9, the multiverse. The theoretical top of the stack coming in at least 4 flavors, none testable. Flavor 1, inflationary bubbles. Cosmic inflation says our universe grew from a tiny patch expanding faster than light. That happened in the first fraction of a second. If inflation is right, it probably never stopped everywhere. It just stopped in some regions, and each stopped region became its own universe, its own bubble, inside a larger, still inflating foam. There could be an infinite number of bubbles, each with different physical constants. Most would be dead, a few would work. Flavor 2, many worlds. This comes from quantum mechanics. Every time a quantum event has multiple possible outcomes, all of them happen in branching parallel realities. Every coin flip, every particle interaction splits the universe into a fresh new copy for every outcome. There's a version of history where you took a different job, another where the dinosaurs never died, a version where I got hit by a bus recording this, all equally real, running in parallel forever. Flavor 3, the string theory landscape. String theory, if right, allows 10 to the 500 ways to fold extra dimensions. Each folding produces different laws of physics. The number is so huge, writing it wouldn't fit inside our universe. Most of those universes would be uninhabitable. Ours would be a rare survivor. Selection bias, cosmic edition. Flavor 4, the mathematical universe hypothesis. The most extreme. Every mathematical structure that can exist does exist. Reality is math, and every consistent equation is a real world. Philosophy dressed as physics and basically untestable. But it's on the list because some serious physicists take it seriously, which tells you exactly where we are. Here's the honest truth about all four flavors. We can't test any of them. Not yet, maybe not ever. They're logical consequences of testable theories, but the multiverse itself sits behind a wall of principled unknowability. Take it as speculation with math attached. So what does this entire 9-layer stack actually mean for us? You're a layer inside layers inside layers. Atoms in cells in a body on a planet orbiting a star. That star sits in a galaxy, a group, a supercluster, a filament. One observable bubble of maybe infinity. At every layer, the physics changes. Quantum mechanics runs the bottom. Chemistry runs the atomic layer above it. Gravity runs the stellar and galactic layers. Dark energy runs the biggest scales. Every layer a different rulebook. Nobody has stitched it all into one theory because the layers seem to speak completely different languages. Humans sit in the comfortable middle. Not too big, not too small. Big enough quantum weirdness averages into solid objects. Small enough we don't think about dark energy at breakfast. Everything strange on this list, it's not a bug. Empty atoms, trillion galaxies, cosmic web, branching realities, it's the design. Reality layered so each scale hosts complexity. Take away one layer and the ones above it collapse. Remove empty space in atoms and chemistry stops. Take away dark matter and galaxies fly apart. Take away inflation and there's no universe to zoom out from. And loop back to the promise. That last layer, the multiverse, it might not actually exist at all. It might be the biggest structure in reality or a story we tell ourselves because our equations won't stop. Both possible, both terrifying. One more thing worth knowing before you go, the recap, quick and clean. 9 layers: subatomic, atomic, planetary, stellar, solar systems, galactic, cosmic web, observable universe, and the multiverse if real. Atoms to infinity in 10 minutes. Next question. How does all this end? Because it does eventually. Heat death, big rip, vacuum decay, big crunch. The universe has at least 4 ways to die. One could trigger right now without warning. I bluntly explain things weekly. Subscribe.